All right, so this morning we are going to pick back up talking about our program that uses a loop here to check for user input and then reacts based on what the user enters. And so yesterday we had modified what we'd been working on to actually do some validation here, which was going to check if what the user had entered was valid, basically if it was a valid digit that we can turn into an integer. Then at the end of yesterday, we kind of left as an exercise doing the rest of the things here. So let's see, Audie, had you done the rest of this and then commented it out? Was that what happened?
Yeah. That's what I did. Yes.
So
I did another problem, so I needed to run that problem. That was why I commented it out.
Well, we can just give it a go then. You know that if you don't call the function, oops, wrong way. If you don't call the function, you can leave the function defined, right? So
okay, that's true.
So it's this line right here. This is the problem line. So why? Oh, it's because those are still commented down. So function definitions don't run. They just define the function. So the probably easiest way to get rid of this is just to do that. All right, but let's go ahead and try running it. And then if it looks good, then, we'll just leave it at that for the time being. And we can then try to break stuff down into functions if you think that'd be useful. Yeah, let's go ahead and run it. Okay, so this is our input. And what we wanted to do was have you add the validation to the add case as well. So here on the add case, we should be able to do whatever. Yeah, okay, so 5 and then let's just verify that our other one is also still good. So now if we try 8 and we try 3, it should be 5. Yeah. All right, very good. So do you have any questions on what you'd finished here, or?
No, I don't. I was able to track everything.
Okay.
I almost decided to try and write the multiplication and division stuff, but I guess I just wait. I should probably have tried anyway.
Okay, so we can go ahead and do the multiplication and the division. Let's go ahead and do those two. It should be pretty fast now because we can copy a case. And then I'll show you, okay, this function is getting huge. We'll go ahead and we'll break the function down into sub-functions here. That will be the plan to start out, at least today. And then after that, I think I will talk a little bit about pseudocoding more. I already did a little bit, and this idea of test-driven development, which we won't talk about tests. So a little bit of that will be hypothetical. Isn't there a unit test? Yeah, unit test. Well, there's a support for it here in this particular development environment, but we'll talk a bit about these things as well. And then I'll set you loose. I saw that you were starting on one over here as well. Right.
Problem is I was working on. I'm actually done with it.
Okay, cool. And there's other exercises. So I think today may be the last day here where we have a video recording where I'm going through stuff, at least for a little bit. I'm not probably the last one ever. I'm sure we can pick up again at some point. But now that we've done exceptions and we've basically had enough examples of loops, we really are going to be free to go and do many things now. So as you'll see, when we have division, we'll have another exception case that we'll have to check. So let's go ahead and do multiplication first. Before this other elif in the conditional here, we're just gonna go ahead and copy this entire statement. I'm gonna go kind of fast. Tell me if you need clarification on anything or you want me to do something else, but otherwise I think I'm just gonna go ahead and do it. So now, we want to edit our initial statement up here. Would you like to add two numbers, subtract two numbers? What we should say, subtract. So we just updated our initial queue to the user to include the new things that we're going to be adding here. And so I started out just by copy pasting the subtraction case, which was an elif here in the conditional. So enter two numbers as digits. Second number will be, rather than subtracted, we're going to say multiplied. So tell me, do you think that this validation case needs to change and this validation case needs to change?
No, I don't think so.
Okay, I think you're right. So the result of this should be is, and we want to say multiple. Okay, so that doesn't exist. We'll go ahead and we'll write that out in a second, but let us do the division case as well. And we'll just go and write the functions at the same time. Kind of weird order there because I copied the first number will be multiplied with the second, not the second with the first. So here we're going to say the first number will be divided by the second. So what we're doing in all of these is that we're following the order of how you would write these expressions mathematically. So if you say number one, then the division sign, number two, you expect number one to be divided by number two. You say number one minus number two, you expect number two to be subtracted from number one, right?
Yes.
Now, multiplication and addition, the order does not matter for both of those operations. So
yes,
it doesn't really matter. We don't have to be so careful in our wording there. But and again, for divide, this and this are going to be exactly the same as the other ones. So now simply we need to change the case divide based on the two numbers. Okay, so not very hard to add more cases, right? But now you see that our function is getting really long, right? And I'll go through and initially go through some general practices for, okay, how do you break down code? We talked a little bit yesterday about where we'd want to break it, right? We said we'd want to break it on these cases here. And then even once we do that, we'll see that there should be something else even that we can break it on. So here, we are going to go ahead and add our two cases here, really simple. We have one for multiply where we said we're going to do that. And we have one for division where we're going to do that. Right. Everything makes sense so far?
Yeah, it does.
Okay, so now let's see if we did it right. So you see, now we have, would you like to, if I can spell, would you like to add two numbers, subtract? Okay, that's just carrying over. I have something in the corner here blocking my view. Would you like to add two numbers, subtract two numbers, multiply two numbers, or divide two numbers? I have 2 question marks. Type add for adding, subtract for subtracting, multiply for multiplying, and divide for dividing. That looks right. So the ones that we haven't tested, I haven't tested multiply. So we're gonna try something, then try a number, try something that's not a number, try a number, it should be 24. Right?
Yes. Yes, it is.
The result of the multiplication is 24. Okay. And then now let's try divide. Not a number, not a number, number, not a number, not a number. It should be 4, right? Oops. You see, I missed updating an error message, right? Because we just did division and that one said multiply, right? The result of the multiplication is divide numbers. So that is a logic error. Okay, so after we fixed very minor bugs, now we're done, right? I'm not even going to go back and test because obviously that's fixed now. And then at the very end, we say exit, we should still leave. All right, so pretty easy, right? Once you understand the structure of how this is working, adding more things isn't so bad in terms of like added time and cost. Now, the problem with this in general is that you see how every time we add a case, we add, let's see, 603 here to 626. That's about 23 lines of code, 24 lines of code to add a new case in how we've written it. That's a lot, right? And so if you were doing something like this and you wanted to add exponentiation or taking the modulus or any other arithmetic operations here, suddenly your function is going to get to be like 200, 300 lines long, right? And then if I tell you, hey, I want you to go change something about a specific case, you have to go digging through the code. And what happens if I tell you that I want you to update the variable name here? So you see how this one says num1 valid and this one says num2 valid? Well, let's say I am, I don't know, a code auditor or something. And I say, you know what, we want to change those variable names. Then you have to go do a find and replace on all the separate occurrences of them, right? You can't just do it in one place because it's not just in one place, right? So what we're going to start with is moving some of this stuff into a separate function. Okay, so you see thus far our functions for add numbers and subtract numbers and so forth, they're taking in 2 arguments and then they're doing the math on them, right?
Yeah.
That's how we've laid it out so far. So let's change this so that we actually put the entire thing here, this entire statement like this inside of the thing. So right now, all that's there is the addition. So we just got rid of all that. See, now we only have 2 print statements here, right? In fact, you see this top print statement? Do you think that we need to leave that top print statement, or do you think that we can stick that in the function too? This one right here.
We could make it a function. It could be an input function.
Well, would we want to make it a separate function, or could we just stick it in the add function here?
In the add function, we could, yeah.
So in general, you want to block, you want to group, kind of like code with like code, right? So in the add function here, we're going to go ahead and do everything relating to adding. So we already have this thing that adds the numbers, but now we're going to add all of the stuff that gets the numbers to add as well. So indentation is not right. Yeah. Okay. Makes sense?
Yep.
So a good principle here before we go do this 4 more times to build out the other functions. You see how now we need to change our arguments here, and now we don't have to pass anything. So we'll get rid of the arguments like this, and then we get rid of the parameters to the constructor, or not constructor, to the just the parameters of the function. Does that make sense? Because now we're getting the numbers inside the function.
Yeah.
Okay. So now the case in our code here for handling if they add, boy, that's not so bad, right? It's 2 lines. 2 lines, right? So now the matter is, before we go do this 4 more times, we want to test and make sure that the procedure we just did works, right? So we want to say add, and not a number, not a number, number, not a number, not a number, number, right? Looks to me like it still works.
Yes, it still works.
Okay. So let's go ahead and do this for all the other ones too then. And we'll go pretty fast here. So if you remember the steps that we took to go ahead and change this, is we take everything that's in the conditional case here. So everything in the conditional case, and then we delete the arguments from the function call, because now we're going to be getting the numbers in the function. And over here, we delete the arguments from the function call, and paste all the code, and then we fix the indentation. Okay, let's subtract, and then we're going to do the same thing for multiply. I actually realized that I missed something on division. We'll go back and we'll catch that in a second. But we're going to go ahead and do this for all of them. Multiply. Okay, multiply. So I'm using tab and shift tab to deal with indentation. Are you familiar with that?
No, I actually thought you were just doing it with tab. Well, tab would actually indent, and the indentation.
So if I bring this to the beginning of the line, if I press tab, it indents it, 1 level. If I press tab again, it keeps going.
Yeah.
And to go backwards, you can either delete these, that works, or you can press shift tab, which will operate on the entire block.
Okay. But if you highlighted the entire block and pressed backspace, it would actually delete the whole
exactly thing. And that's why you need shift tab. So on the entire block, tab indents everything, shift tab unindents it. Make sense?
Yes, it does.
I just wanted to make sure you knew. And to comment and uncomment, you remember that the command we said was Control K
AC and Control KU.
Yep.
Yeah.
Those are important keyboard bindings here. Okay, so this is multiplication, and just one more here with division. And you can actually backspace entire words by pressing Control backspace too. That's another useful one. Okay, so now we split everything. Let's go ahead and check and make sure, now that we've done this, that all of our cases still work. But now you see that our main function here, 700 or 679 to line 707, this is not nearly so bad, right? But now each one of these functions, not so bad, but I'll talk about something else in a second here. But let's go ahead and check for now. So we're going to go ahead and we already tried add after we moved it. So let's try subtract now. Not a number 7, and then not a number, and 4 should be 3. Yep. Now, one thing that I noticed here is that I left this thing as an example here. Basically, this was the first way we'd done it with the wall true, and then we refactored and we said using a variable actually kind of makes the code more readable, right? So just because this one's the odd one out now, rather than leaving it, we'll actually just go ahead and we'll make it look like the other ones, right? See what I just did? I didn't do anything weird. I just did exactly the same that we did up here. And this is exactly how you've done it for the other ones as well. Well, actually, no, whatever. I guess I copied the one where we had it that way. Well, actually, this code block, hint, 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 watch this. This code block can go there. And it can also go there. So based on what I just did, do you see something? If I can just copy paste the code block there, what should be jumping into your mind right about now?
We could make a function out of it and simply call it direct.
So do you think we need a separate function to get the first number and a second number to get a second function to get the second number?
It seems like one function can do both.
Because we just need to call it twice, right?
Yes.
So let's make a function called, let's make a function here called get digit user, right?
Yes.
So it's not going to take in any inputs. And we're just going to copy that thing that we just did here. And rather than num1 and num2, we're just going to check if the number is valid. We're going to make the code kind of general. So we say num valid is false, while not num valid. And we're going to ask the user for the number. And in fact, we should have a parameter because we are going to be clever here. And we're going to say, so you see, the problem now is that we have print statements here that depend on order. And so you say, uh-oh, we can't make this a function then. Well, yes, we can, because everything is shared there except for one thing in the function. And can you tell me what is the one thing that we can't share? Just generally, if we copy the code.
Yeah, the print statement that says number one.
Now, is it everything in the print statement or is it just part of the print statement?
Just part of the print statement, the number one.
And how about number? Is number different?
One.
It's just
no,
this.
number is not different, just one, yeah.
It's just this right here. Everything else is the same about all this code except for that right there. So
yes.
At the end of all this, by the way, we are going to want to return simply. Right? Okay. So that is what will get this. But now to make this generic, what we can do is we can pass, well, let's call it position, or position would be fine. What we're trying to come up with a variable name to pass here. So I'm going to say, just trying to think of a good variable name for this, something that's descriptive. So it's basically which time the user's called this function, right? Look, is it for the first number or the second number? So I will say, it's kind of a hard thing to come up with a variable name for.
Those first and second, but we need it to be generic, right? Not first and second.
Well, right. We're not. I'm not talking about hard coding it here. Let me just do it, and then you'll see. So let's say we just say operand. Yeah, that's a good variable name, right? Which operand are we getting in whatever operation we're doing? Are we getting the first one or the second one? So we're going to go ahead and use a format string so that we can inject the variable. And that makes sense?
Yeah.
So now we're just going to use this variable value rather than whatever we had there. Okay, so now we need to come back through and rewrite the code that we've been doing to use this that we just did. Okay, so here is our function. In add, we're going to replace this whole thing with just a call to this, and we're going to say num1 is going to equal this, except we need to call this with something. And here, we're going to call this with 1. And for num2, we're going to call it with 2, right?
You change the second num1 to num2.
You're correct. Does that make sense?
Yeah,
and now
it does.
we can actually do this. We can do this for all of these. And so you see, if you remember exactly how big our code was just a second ago, now this is the code for getting a number. This is the code for adding, subtracting, multiplying, dividing. And then our main program code, you know what, we can actually get rid of this because we don't have anything very complicated here. Our main program code is really not so bad, right? It's only on the order of maybe 20 lines here. So it fits on a screen, right? Basically. And the only logic that it has is it's switching. It's basically doing a logical branch based on what the user inputs. And you can't really make this any smaller, right? There isn't a good way for us to make this smaller. We wouldn't want to anyway, because we want all the logic to be in a single level in one place. So this function is now broken down ideally. This function, you know, divide, multiply, add, and subtract. Is there any way that we can really break these down more?
Nope.
Like, do these share any code really in a way that we want to refactor more? I mean, they all get number 1 and number 2, but you can't really like not get number 1 and number 2, right?
Yeah, yeah.
Now, one thing we could do, I prefer what we have right now for readability, but if you wanted to actually get rid of the lines here, you could actually replace the variables with the function calls itself, right? Like that.
Then the first 2 lines, yes, I see.
But why am I returning a semicolon there? Habits from C#. So you could do this like this and just not use the variables, but in my opinion, that's less readable than getting the 2 numbers and then making it clear that what you're doing is an operation on 2 numbers, right? So I actually prefer this, even though technically it's 2 extra lines of code. I mean, it's 2 extra lines of code. Why are you complaining? It's 2 lines. So in my opinion, I like this format. Very commonly, I like to use variable names for readability. It's a big deal because the bulk of the time that you spend dealing with code isn't going to be making it, it's going to be like sustaining it, maintaining it. Someone in the future is going to have to read this. And if they read it and they don't know what it's doing because you're just doing a bunch of operations without using any variables, and variables should always be named something that's helpful. So here, you know, we're getting number 1 and number 2. And in the future, when someone reads this, they'll be like, oh, okay, they're getting numbers with this function, and then they're going to do something to them. It's really clear what the code does. If I just do this, in this specific case, I don't think it's too bad. Like, I don't think it's that unintuitive, but I still think this is clearer, right? And so you should always be thinking along these lines when you're programming as well of, am I calling my variables and my functions good things? Function names matter a lot too, because here we're saying the result of the addition is add numbers, right? If we call this something strange that doesn't involve the concept of addition, then it's kind of confusing when someone else were to read it, right?
Yeah.
Okay, but what I really want to emphasize is how important code organization is. So the principles we followed here was if you have something where the logic is easy to separate, break it up into functions, right? And by easy to separate, I mean that we had a case for addition, we had a case for subtraction, we had a case for multiplication. Each one of those things could be handled separately, right? Yeah, if you want to get your function size down, well, those things are really good. Those things are really good options to split on. The other thing that should get alarm bells going in your head is if you're copy pasting the same code over and over again, you should 100% reuse that. So if you remember earlier, I think I mentioned this principle is called DRY, D-R-Y, typically written all caps as an acronym, means don't repeat yourself. Don't repeat yourself. Keep your code dry is what people will say. And what that means is that anytime you have something that is being used repetitively, you should break it out into a function. And then you should call the function rather than copy pasting the same statements over and over. Because here, you see, if our auditing person tells us, hey, I don't like this variable name, change this variable name. I'm just, not that someone would audit you on variable names, but let's just say, or in peer review or something, you're putting this code up for peer review, or PR as we typically call it. And one of your teammates or one of the other people at your company is looking over what you've done before you go ahead and you pull it into the main code base to make sure that what you have works and that it is logical and that you've named your variables well and that everything looks good, basically. And in that process, they say, you know what, like, let's say we named this something, let's say we named this something bad. Let's say we just gave this variable name X, okay? This is, I don't want to say a common mistake, but a lot of new programmers will just give variable names like letters or something. Well, when we assign X equal to false, someone who's programmed before will say, okay, X must be a variable and it must be a Boolean variable. But just by looking at this line, X equals false, I have no idea why this matters to me. Why does it matter to me that X equals false? Whereas if we leave it at the descriptive variable name we have, if I say num valid equals false, okay. So we have a variable representing if a number is valid. And if num valid is false, that means the number isn't valid. It means something to me, right? It helps me read and understand the code. And so if I had left this as X equals false, you know, and then we used a bad variable name, something that wasn't descriptive and helpful. Well, if we had hard coded this value, right? Or not hard coded. If we hard coded this this operation of getting a number and we had it, let's see, 1, 2, 3, 4, 5, 6, 7, 8 times, you would have to go change it in 8 places, right? Whereas when this circumstance happens here, you only have to change it in 1 place, right? Does that make sense? So there are huge maintenance and practical benefits to using code that doesn't repeat itself, because you pull it all out in 1 place and you only have to change things 1 place. Plus, it's just easier to understand. If someone's going through and they're looking at your code, they only have to review a lot less lines of code right here than they do if you don't break it out like this. And it also follows that idea. I think I've talked about this before. You want to keep each function basically as dumb as possible, right? Because if you break down your code appropriately, bigger functions get broken into smaller functions, then you only ever have to understand one slice of the pie at a time, right? So for example, from the perspective of our program loop here, it doesn't really care how the addition of numbers happens. Like, it really doesn't. All it cares about is what do you get when you add numbers, right? You know, we want to do the add operation when the user picks add. That's the only level of complexity we care about when we're inside this main loop here. And then when we go to add, we see that adding numbers needs to get numbers. Well, does the add function, like conceptually, do you need to understand how you get a digit from the user to add a number? No, because getting a digit from user has nothing to do with adding, right? And so we call something else to handle this part because we don't really care about it. Not here. And then getting a digit from the user, well, we can't really break this down. There's nothing that breaks out well here. And so that's where we have the try catch or try except in Python. Does that make sense? So I just want to emphasize again how important what we're talking about is. Naming your variables, good things, naming your functions, good things, and breaking down your code so that you use this idea of encapsulation. I think I've talked about that before. You know, managing your complexity, so you're only looking at a small set of what you need to do at any one point in time, and you have functions that call other functions that call other functions. If you do those 3 things, your code will be way, way, way easier for other people to read and understand. And that's really important. Now, something else on the topic of good code style, generally, people would want you to write comments. So in Python, the typical way to comment a function is to use 3 single quotes like this. This is called a docstring comment. So we would say, I mean, usually there's like a standardized format for this. If you are interested, you can Google it. You can say this returns or how about we say gets two numbers on the command line from the user. So it describes what the function does, basically. And so if someone wanted to know what does this function do, they can read the comment on the function. And that will describe, usually it's the docstring comments. If you're commenting a function, you should describe to the user what the inputs to the function are. So if you have arguments, what each one represents, and then also what the return values of the function are. So right now, each of these functions returns an integer. However, if there was an error case, you'd want to explain what the error case is, like when it occurs and what the point of the error is as well. So you want to talk about inputs and outputs, input state, output state, and kind of just at a high level what the purpose of the function is. So if we were being precise, you'd want to comment it. Now, I will tell you, I work in a production environment. I mean, we push code, we deploy in the whole 9 yards. And actually, we comment. We're supposed to comment all of our code. I will say that is not. It doesn't have nearly as much priority on it as naming your variables well and naming your functions well and having good code style in general. Clean programming, breaking things down well. We will straight up reject a peer review if none of that's there. If the comments aren't there, technically we're supposed to do it. And we do it, like I would say 80-90% of the time. But every once in a while, someone forgets, and then we forget when we're peer reviewing. In fact, we just made a checklist to try to hold ourselves to higher standards. We'll start doing that soon. But the point is that from a programmer's perspective, all of us think comments like the general, here's an input, here's what it does. Those aren't really useful to you when you're a programmer, because if you can read code, you can just look at the code and see what the input does. Like, why do you need someone to tell you, right? What the comments are for is they're for maybe people who are not familiar with the language, or for us, in our opinion, they're just a requirement that someone decided arbitrarily that we need to do. So I don't want to diss comments, especially if things get complicated. You should 100% comment your code. But when I say comment your code, that's a different kind of comment than saying, here's a function that does blah. That for you as a programmer isn't very useful, because what you can do is you can just look at the function and see what it does. Those sorts of comments are usually because your customer has a requirement that everything be commented. One more note here is that in many integrated development environments, so this holds for Python, this holds for Java. Java has something called JavaDoc that has a standard thing where you do like at arguments. I don't remember if it's arguments or something else, or I think maybe it's just like parameters. And then whatever you can, like, you give the name of your parameter, and then you can do like what it has and what it returns. Is that if you've ever seen when we're coding something, if I do something like my string equals, I don't know, and then on the next line we want to like split on the string, we would do something like my string. You know how this thing pops up?
Yeah.
Well, if you comment your functions, if you put docstring comments on them, you can actually have your development environment pull this menu up when someone else is trying to use it, right? And that's actually really helpful, because then someone can see what the arguments are and what it does, right? So that is really the use case for docstring comments. And you should 100%, if you have something that's hard to understand or complicated, you should 100% leave inline comments that don't explain what the function does and the inputs and the outputs, but just explain what the code's doing. If anything is not, here's the standard my team uses. If anything is not quote unquote immediately obvious, it should be commented, everything. However, the problem with the statement I just said is, well, what is immediately obvious? That means different things to different people. Specifically, more experienced people will kind of look at a comment and be like, well, I didn't need that. I can see what the code's doing. Why do you need to explain it to me? Whereas newer people, people who are more recent to when they got hired, or at least when they switched on to our team, which has a certain way of doing things and stuff, Well, sometimes they'll look at the code and be like, I have no idea what that's doing. Can you explain it to me? Right. And so it does vary by experience level. However, the benefit of commenting your code is that even for experienced people, sometimes it's faster to just read in English what the thing does rather than sitting there and squinting at it. Right. And the other thing is, you're going to have to, like I said, the biggest part of dealing with code base, this is something that a lot of people coming out of college or just learning programming in general, they don't understand. The biggest part of programming is actually not writing new code, it's dealing with old code. And if your old code is really convoluted and hard to understand, it's going to make your life way harder in the future. So you can do yourself a favor by writing good, clean code and commenting it effectively, even if you're like, you know what, right now, I don't need these comments because I just wrote the function. And this is the trap that people fall into. You wrote the code. Of course, the code makes sense to you. Comments aren't for you, right? The comments are for the you of 6 months or a year, because you might have to use your own code eventually. Well, if all this is fresh in your mind, you're not going to need the comments to understand it. But how about when you come back and you look at this in a year? Will it still be obvious to you? And actually, the answer, I can attest to this, okay? I've started writing some of the stuff where I want to do like file management on the command line. I started writing it in Python because Python in general is much easier to understand. I have a collection of scripts written in the scripting language called Bash. That's a shell scripting language. Bash is completely impenetrable. Like the way it works is I mean, I don't want to say dumb, but like it is not obvious like Python is obvious. And so I'm starting to convert some of the scripts into Python so that I can go back later, because in Bash, to like enumerate all the files in a directory, for Python, it would be something like 4 files in directory, right? Something like that. In Bash, you have to do all this complicated other crap to just do something like that. So I'm just using that as an example of, in the real world, even in my own life, I have come across situations in which I haven't commented, code I've written, and I come back to it months later, and then I have no idea what it's doing because I didn't like just write it. So sorry, I went off on a little bit of a rambly tangent here, but code style, good variable names, good function names, breaking functions down so that each of them only do one thing and one thing only. By the way, another side tangent is that what I just said about functions, that makes them a lot easier to unit test too. If your function does 50 things, then you have to test 50 things in the test case. But if each function only does one thing, it makes it much easier to test, does it do it correctly or not? We'll get into tests later. One last thing that I wanted to do here, and I mentioned this, and then I kind of waited until we finished refactoring. That's what we just did is called. It's called, if you're not changing the functionality of what your code does, you're changing the organization of it. It's called refactoring.
Okay.
Our team actually does it a lot. Typically what will happen is we decide that the way we did something code-wise is just like not ideal. Maybe it's harder to maintain. It requires us to hard code stuff rather than using something like a function call, the equivalent of that. We'll talk about generics eventually. If you can use a template to do the same thing rather than having to write it out 3 separate times, and inheritance in object-oriented programming, another concept very similar to using functions and something that's shared rather than something that you have to do each time. All of those things are candidates for refactoring to make your code better to maintain over time. But the one thing that I want to do here is let's try to divide, and then let's give the first number 6, and let's give the second number 0. Now, this is not a valid mathematical operation, right? Technically speaking, if you do division, you take the limit, you can do things like this, but not in normal math. 6 divided by 0, you can't do in normal math. Interestingly, completely unrelated side tangent, did you know that when we have a sonic boom, if an airplane breaks the speed of sound, you actually divide by 0 in the Doppler equations? Like you actually do. The Doppler equations describe the Doppler shift, which is if you ever have like an ambulance go by you, the sound frequency changes. But I think that's so cool, is that sonic booms are nature dividing by 0 in the sound equations. But anyway, we can't do this. And so you see, we get an angry red error. And you remember earlier, we decided that, like we don't want errors. Errors are bad, especially errors that crash the program, right? Because this is crashed, right? Like if I type in add, like there isn't anything running. This terminated our program. That's not okay, right? And so this case will only happen with division, and only division where the second number is 0, right? So there's actually a way for us to handle this. But let me ask you 2 things. So I just said that the only place where we care about this is division. And here, this function that we've written to get a digit from the user is not specific to just division, right? So
yes.
Do we want to throw an error here? Let me do another example, and this should answer the question for you. Let's say we want to add, we get the first one 5 and we get the second one 0. That's a valid operation, right? So we can't really disallow 0 here in this function, but where do we want to put the check if something is 0?
And the divide numbers function.
Specifically, where? Well, I just did it, but I mean right here, right? And we want to check if number 2 is 0, right? Because number 2 cannot be 0. So all we have to do is say if num2 is equal to 0, right? And we should probably print. Actually, let's do it this way. This will give you more exposure to errors. So we could print something, but then what do we return if we just print something here? Because really, what we want to do is we want to stop the whole execution. So because if we don't do anything here, then we'll get back to the divide case and it will still try to print something. Well, let's say we just return nothing. It's still going to print the result of the division is whatever we return, right? So we actually want to stop execution when this happens. So what we can do is rather than doing it here, we can wrap the whole thing in a try except statement here. So here in divide, we know that we can have a division by 0 error, right? And actually, you know what? Now that I'm thinking about it, well, let's do one more set of refactoring here. So the problem we're having is that we're trying to print a string external to the divide function, right? So we can't just try except in the divide function. But there's really no reason for us to do that, right? Because this statement here, the result of the division is, well, rather than returning this, why don't we just put the print statement right inside there, like that? Does that make sense? And then down here, the only thing that we do is we call divide numbers. And why I did this, you'll see in just a sec. First off, this is cleaner, right? This is better. I don't know why I didn't see this before, but hey, it's morning. Also, like this happens a lot where sometimes you just don't see something that's better for whatever reason. And definitely better to have this code in each one specifically, because then it keeps this even cleaner. So the reason why I just did this actually is that probably the best way to do this, rather than trying to, we could either put an if after number 2. So there's 2 ways to do this. Let me go over both. One way is to actually try accept this. And so let's be precise in our code. Division by 0 error Python. So there are different kinds of errors, right? And specifically, we want to catch the divide by 0 error. Okay, Stack Overflow, every programmer's best friend. Well, that's not helpful. I want to know what the name of I want to know 0 division error. That's it.
Yeah.
So we're gonna do that. And then if that happens, we want to print something helpful, right? Doesn't have to be anything real specific, but how about the second operand not 0? So this would work. Now, if we do this and we get into this section over here on division, let's see what happens. because this will handle the error appropriately. We could also, I said we can do 2 ways. Let me show you the other one. Both of these are going to be equivalent in how they handle it. We could also, before we do the operation, we could check this, and we could put this print statement right here, and then we could just return after that to terminate execution before we actually do the division and throw the error. Do you see?
We would have to define the condition if num2 is equal to 0. Right?
Sorry. Yeah, that. Yeah. Yeah, sure, we should do that. Both of these things do equivalent things code-wise. Well, you know, like this. Well, this statement would have to be. This statement would have to be after this conditional check in the code. So this right here is one way to do it. The try except is another way. Both of those will do the same thing. You can just take my word for it, or we can run it if you want to actually see.
No, I understand. I expect it to work.
Okay, so let's try this and let's do divide. Now let's see what happens when we do this now. So now we don't want any runtime errors, right? Okay, but what's the problem with what just happened here?
It takes you back to the top of the program instead of giving you a chance to enter a new number for num2.
Okay, here's where exceptions are going to blow your mind a little bit. So we said both of these things are possibilities to handle it right here in the function. Okay, but we can actually catch the exception in the higher function. We don't have to pass any variables or anything. This is common to all exception handling across programming languages. So we know right now, we know that divide right here, we know that this could return an error, right? But down here in our divide, you know how we had validation functions? So how about we make a function here and we call it division by 0.
Okay.
Or, you know what, let's. Autocomplete. Autocomplete is such a habit once you become a developer that when you don't have it, you feel crippled.
Okay.
Does this make sense? So as long as they're trying to divide by 0, or actually, you know what? Sorry, I don't know what I was thinking of the validation, and we were doing it the other way. What we should actually do is we should try this, right?
Yes.
And
that should be except.
Okay, so I'm trying to think about the best way to do this. We can actually have, you know what? Let me do it like that. Division. There's actually multiple ways you can go about this. I just have to leave soon, so I'm just trying to think of a way that works so I can show you because I have work in like 10 minutes. Divide numbers, and then here we would do does this make sense to you?
Not clearly. I thought division by 0 should be set to false, and then I don't know.
So division by 0 is set to false after we successfully divide, which will break us out of this loop, right? We'll stop trying to divide numbers. However, it is absolutely allowable to have the except to what we do here be like that. You could also do pass here, which means literally, it literally means do nothing. because division by 0 is starting out true, right? So we don't really need to set it to true again because it's already true. We're going to keep iterating as long as this is true. So as long as we don't set it to false, we're going to keep going, which is why you can do pass.
I see. So it'll keep trying to divide the number until it gets the value.
So we said we want to be on the divide case. Right? Okay. So now the only issue is, okay, you know what? I'm being dumb. We actually have to print the error message there, right? Otherwise, it just prompts them again, and it doesn't do anything, right? So we said the error message we had here was the second operand cannot be 0. Please try again, right? We actually need to put that in the except case. Otherwise, the user isn't told anything. Bad UX, right? So this is probably more readable. You can use pass though. They can also use pass. But this is very clear that as long as what they're trying to do is division by 0, we're gonna keep trying, right? So let's try again. Divide 6, 0. Second operand cannot be 0. Please try again. Enter 2 numbers of digits. Yep. That looks like what we want, right?
Okay. So they'd have to enter both numbers again. Okay. Is there any way to just make it the number 2?
Just the second one, huh?
Yes.
So
that would require writing more code, wouldn't it?
Let me think for a second here. So you see, we put this in the top one, right? Let's move all of this logic. That's actually a good catch. I haven't been thinking about that, right? So there's actually technically nothing wrong with what we're doing right now. It just does require them to re-enter the first one, right?
Should that be under number 1 or number 2?
We don't want this to be here. You'll see why I'm doing this in a second.
Let's see.
This is actually better too, because it keeps the exception handling inside of this function here. Okay, so we're going to try that. And let's move the rest of this down. And then see, this stays dumb. Remember what I said? We want every function to stay as dumb as possible, and only do the things associated with it. Okay, so if we can do the division successfully, we're going to break out. And if we can't, then what we should do here is try to get the second number again, right? We're pretty sure that's what we want, I think, right? And let's, does what I just did here make sense? Like I said, I'm sorry I'm going fast, but I do have to leave soon and I want to kind of conceptually finish this today.
The brain is lagging a bit, but it's catching up. I think I get it.
So this is exactly what we just did down there, except now we're doing it just when we get number 2. Not for the, see, previously we had been calling the division function in a loop. We've been calling this function in a loop, right? And now we're switching which function we're calling in a loop. Now we're calling the attempt to get the second number. Now we're calling that one in a loop. So I think this should work. Let's go ahead and verify here. So we're going to do divide. And then here, so it says enter 2 numbers. So first one, okay, number 2, second number cannot be 0. Please try again, right? 6 and 2 is 2, right?
Yeah. So that makes total sense. Yeah. I get it.
So you see, even I didn't get this quite right the first time, because sometimes you have to think about it, right? You have to think about what's the best user experience for the person on the other end of the application, right? And you are 100% right that just having them enter the second number again, that's definitely the best user experience, right? But at least, you know, making them you know, at least making them not have to pick division again is better than making them have to pick division again, right? So like there's kind of stages of bad here, right? But we want to be at the best stage. We don't really care about the ones that aren't best because we should only really seek to implement best.
Yeah. Okay.
All right.
Well, that makes sense. But you said this would be the last one. We still haven't done the testing. You did say we would do that.
Yeah, we can do tomorrow too.
Practice.
It's fine.
Okay.
Typo. I do not think we will go nearly as long tomorrow. You can keep going on your programming problems. You know, I think you got this one. That's what it looks like to me. You know, sounds scary, right? But it's really not that bad.
It did. It sounded scary, but it turned out to be pretty simple. I was quite surprised.
Well, I had done this intentionally, right? The hardest part of programming isn't necessarily always just writing the code. Sometimes the hardest part is figuring out what you're supposed to do. I don't know exactly what primary education is like in your country, but in our country, right around third grade, fourth grade, you start getting these things in math, and we called them word problems, right? You know what I'm talking about? And when you're in third grade, you can do things, you know, fancy schmancy stuff like multiplication and maybe even division. But as soon as someone tells you, you know, like Johnny has 3 apples and then he eats 2, how many apples does he have left? Okay, that one's not so bad, but you know, they get worse. Oh boy, word problems. No one likes word problems. Physics in high school, if you ever took physics is full of word problems, and you have to interpret the problem and turn it into math. And for us as programmers, you have to interpret the problem and turn it into code. And a lot of the time, it's that process that I'm just telling you right there. That's what takes more time, not actually writing the code itself. Because once you know how to code, coding itself is just kind of, you do the thing. So I will say, in the last year or so, I have shifted, you know, I'm a team lead, and my job description, I've shifted a lot. I've written a lot less lines of code the last 6 months than I did before I had that responsibility. A lot of what I do is what I just said. A lot of what I do is, so the user wants the program to do this. How do we turn that into code, right? Because I won't actually write the code. I'll just organize the work so that I tell someone, okay, you need to do this and this and this, right? Like, so for example, use a loop to read in input from the command line. That's how you get a number from a user, right?
See.
And then anyone who knows how to program can write the loop, right? I just say use a loop to do it, or do this or do that, or store the data in such and such a format, right? So it's the translation from the word problems, from the customer requirements into the general pseudocode, or basically, how are we going to do this? How are we going to tackle this problem? Sometimes that takes a lot of time, to the point where, you know, it's funny, you know, I'm paid as a software engineer, I'm paid as a programmer, and I actually don't write that much code. I mean, I still write some code, don't get me wrong. I still help get people unstuck on my team and stuff, but like, I don't write as much as I used to, because now a lot of my job is figuring out how are we going to do this? And usually, actually, that's the harder part, the coding. You know, hypothetically, sometime in the future, I'll get paid more because of this. Now, right now, because the government pay bans, it's kind of funny. I was talking with someone else about this. The other 2 people who are equivalent in my position on our team. So we have 3 sub teams on our wider dev team. We're all working on the same application. Those guys get paid like $15,000 a year more than me, just because they've been here longer. But I'm doing the same things they are. It makes me bitter. But you know, like, it's fine, you know, but anyway, I need to go to work. But you know, this thing that I'm talking about, this translating from the problems into code, like I said, usually that's the tricky part. And it's why this example here, it looks scary, right? I have a raise. I need to know what kind of thing it is. How am I supposed to do that? All you need, this was exactly what I was testing here. Did I give you any hints here?
Yeah, you did.
Write a function.
Takes in the 3 credit lists and the name of a new credit acquisition return.
Right.
Okay.
Well, I mean, the hint here is that you should use the operator here that checks if something is in the list. Because if you do this one's really easy. If you don't do this, I mean, I said don't use loops too, because you could also do this with the loop. Like for bird in birds, if critter equals bird, return true. See what I'm saying? Like,
yeah.
And for mammal and mammals, if critter equals mammal, return true. Like you could do it that way too. But this way, you don't have to write any more code. This is the better way because it uses something that's already built in. So anyway, go ahead and you can keep working on the programming exercises, the ones you haven't done, if you still have time. And tomorrow, we will go over, I mean, specifically, you can start the ones with loops too here, right? If you get to those, it looks like you still have a couple left up here as well. Or actually, I think.
I already did it.
Yeah. Okay. Well, we'll talk about this. This actually wasn't what I had in mind for doing this one, but we'll go over that at some point as well. I mean, it's not wrong. Like I think it'll return the right answer, but
maybe to do it then.
Yeah. I mean, go ahead and see how far you get on the other ones, but tomorrow, I don't think this discussion here. I mean, I talked a lot about good code practice, good code style today. Pseudocoding is another thing that helps you write good code. It helps you break it down, basically. So this thing that we did up front, where like, you see how first we like wrote the big function and then we like broke it down and stuff. Do you remember yesterday I was talking about the difference between like coding by the seat of your pants and winging it versus like the people who plan everything?
Yeah.
The people who plan everything, they generally don't refactor as much because they kind of think it through beforehand. Arguably, you can kind of see why those people get smug and they think that they do a better job than us because they say, well, look at those guys. They have to go do so much work, like changing their code around and stuff. My argument against that is, well, copy pasting doesn't take very long. And if I can write it faster, just doing it, you know, because for them, they have to spend all this time sitting there and like writing pseudocode, which is not real code. You can't run it. So, you know, pros and cons. Remember, I talked a good bit yesterday.
I really don't like duplicating efforts myself. So I don't like duplicating efforts. I want to do something once. And once
that's exactly why I'm not the biggest. I mean, you will do it sometimes to even wrap your head around a problem. You have to think about it a little bit and at least like come up with proposed solutions. But I'm not going to go sit there and do the whole thing in pseudocode. Right. So it's kind of like a continuum. Right. Anyway, I really do have to go now. So we'll meet again tomorrow morning. We'll knock out the rest of general discussion stuff on coding practices. And I don't think this stuff will take super long. And then we can go over any questions you have on the exercises here. And then after that, I will release you for a little bit. And remember that one day you were working and you were like texting me questions? That works fine.
Yeah.
We'll do that for a while. Just get you some practice for all of this. But this example we had here now, where we had many multiple subfunctions and the program that actually uses user interaction. Hopefully this has been a good, solid example, you know, the next step in your process of conceptual understanding, because it's bigger, it does more things. The other thing that you can do here, I see I only did it for divide here. You could split these out so you put the print statements inside the other functions, right? I did say that was better because it makes this more readable.
Yes.
Even if you don't. All right. Well, I will talk to you again tomorrow then.
Okay. Have a great day. Thank you.